All right, so uh, I'm going to teach you about a new number. Now, hopefully, you know of pi by now. You know, pi is some infinite number. 3.141. What am I doing? 1592. I think that's right at least. Whatever it is, dot, 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 dot. Going off to infinity, right? Well, there is another one of those numbers that we don't talk about as often because it only comes up in higher math, and that's the number e, specifically italicized e. This is a natural base number. It has some fancy things in calculus, and because of that, they actually created a logarithm just for the number e. That logarithm, excuse me, is ln. ln is kind of like, I assume I've told you this by now, but once again, in case I haven't, just like log. Log is known to have base 10, even if it's not there. ln is just like log with a base of e. Those two are exactly the same thing. So, if we want to write something like this, next one here in logarithmic form, we do the same thing. We flip these two things sides. We write ln because that's naturally base e. We don't actually put the e there. Ooh, that's horrible. And so we end up with that. So, do note, once again, that we're switching sides there, and this is on your calculator, so if you ever have to find this, you can just hit on your calculator and be done. So again, switch these two things sides. Which gets me that. Okay? Doing the opposite in exponential form, once again, switch them, put the e on there, end up with that. Switch them. Technically, it should be switch and drop that, right? Ooh. Okay. So, then to simplify, those same properties we just used are still applicable, meaning numbers in front can go to powers. Which ends up as, since they're numbers, I can write that, correct? Then subtraction ends up as division. And using a calculator, we can check to see how many times 8 goes into 1,000. So 1,000 divided by 8 actually works out to a nice even 125. So I can write ln of 125. Do note that you could use your calculator once again to solve that. I'm going to go ahead and pull that up so we can do that real quick. So, calculator. So, all I have to do is I'd have to type ln of 125. You see the ln right there, hopefully. Enter. So I get an answer of 4.828. Okay, so I'm going to go again on this next one. Number can go up top. So I end up with ln of 40 plus ln of 4 to the 1/2 power, which hopefully by now you know that's the same as a square root. So then I could rewrite that as natural log of 40 plus the natural log of 2. Addition ends up as multiplication. Subtraction ends up as division. So because of the variable, I can't actually solve this one, but I could write it as natural log of 80 all over x. Do note on the first one, you could have just done that in your calculator. That one would have worked just fine. Okay, solving. Solving, we're going to treat e kind of like it's an x. So what you do is you add 12, Divide by 3. Divide by 3. Then to get rid of e, all you have to remember is put ln on there because the bases cancel. And so I end up with 4x equals ln of 9 divided by 4. And since my calculator already died on this computer for some reason, I will just use a calculator here in IRL. I never actually said IRL out loud, so that's kind of funny. Anyways, unless my calculator doesn't have natural log on it. Oh, there it is. Natural log of 9 in my parentheses and divide by 4. I get an answer of 0.549306, whatever I have to round to, obviously. I could do from there. Solving one that looks like this. Move this to the power. Then, to give it a natural log, I put an e here. That's going to cancel that out. And actually, that whole thing is to the 5th power. So I end up with 6x e to the 8th. So first thing I want to find out is what is e to the 8th. Oh, I'm going to switch calculators because that one's a little too smart for me sometimes. So e to the 8th. Then I have to take the 5th root of that answer. So right now my calculator shows me this. To finish it off, I get that if I round to 3 decimals. Okay, a common use of the base e is the PERT equation, which is key to note. The PERT equation says this. Every time you see these words, you can immediately jump to this. And yes, you will see these words at least in college algebra and probably a few times beyond that. Maybe even statistics if you have to take that. Where P, just like in the other interest equation, is your starting amount. R is your interest rate and T is the number of years. Notice there is no N in this one if you remember the other equation because the E takes care of that. So if I have this equation, 8,000 is vested at 3.75, compounded continuously. Once again, that immediately points me to this equation. How much we need to count after 30 years? So I take 8,000 in front. And I have E, my rate. You always change it to a decimal, so just move it twice, right? 1, 2. Times 30. All I got to do is use a calculator to solve that. And then you can literally just type it in. The E, by the way, if you get second L in, that's the easiest way to get it. So you can write that down. Once again, second L in. This gets me after 30 years. 24,641 with 73 cents. Ooh, 73 cents on top of it. Okay. Sometimes we'll ask a question like this. Find the rate necessary to make 10,000 become 30,000 if 18 years compounded continuously. So I do the same thing. Have your starting amount. We know it needs to equal that amount. We want to know the interest rate. And sometimes do the opposite. They'll give you an interest rate and ask how many years. But it's the same process. You always start by dividing that first number off, which hopefully you can all do that math in your head and get 3. Then once again, to give it a V, we do ln. So I have ln of 3 equals 18r. And I'll just do my division all at the same time. So all I need to do is type my calculator, ln of 3, make sure you end your parentheses, and divide that by 18. So ln 3 divided by 18 gets me an interest rate. My calculator is showing me this. So obviously, in order to show an interest rate, I need to move the decimal twice and write that. Okay? If you have any questions, you can always email me or come see me. Otherwise, have a good evening, and I will See you soon.